Hi everyone, I'm Dr. Maria. Today we will discuss about the Scientific American fact and mysteries of the chemistry. Can compounds be made out of carbon? Question is, um, can computers be made out of carbon? Molecules, human bodies, compounds are made up of carbon. A strange word is that can computers be made out of carbon? Let's see. Computer chips made of graphene, a web of carbon atom, and could potentially be faster and more powerful than the silicon-based ones. And the discovery of graphene garnered by the 2010 Nobel Prize in Physics. But the success of this and the other forms of carbon nanotechnology might ultimately depend upon the chemist's ability to create structures with atomic precision. Precision is basically accuracy. Discovery of buckyballs and hollow cage-like molecules made entirely of carbon atom in 1985 was the start of a something literally much bigger. 6 years later, tubes of carbon atoms arranged in a chicken wire-shaped hexagonal pattern like that in the carbon sheets of graphite made their depth. Being hollow extremely strong and stiff and electrically conducting, these carbon nanotubes promised applications ranging from high-strength carbon composites to tiny wires and electronic devices. Miniature molecules and molecular capsules and the water filtration membranes and electronic devices and the tiny wires, high strength carbon composites, basically. For all their promise, carbon nanotubes have not resulted in a lot of commercial applications. For instance, research have not been able to solve the problem of how to connect tubes into complicated electronic circuits. More recently, graphite has moved to center stage because of discovery that it can be separated into individual chicken wire like sheets called as graphene, and that could supply the fabric for miniaturized strip and robust electronic circuitry. You can say this hope is that computer industry can use narrow ribbons and networks of graphene, which is made to measure with the atomic precision to build chips with the better performance than the silicon-based ones. Graphene can be patterned so that the interconnected and the placement problems of carbon nanotubes are overcome. And Similarly, says carbon specialist Walt T. Here of the Georgia Institute of Technology. Methods such as etching, however, are too crude for patterning graphene circuits down to the single atom. He here point out as a result, he fears that graphene technology currently owes more to hype than hard science. So using the techniques of organic chemistry to build up the graphene circuits from the bottom up, linkage together polyaromatic molecules containing several hexagonal carbon rings, like little fragments of graphene sheets, might be the key to success precise to atomic scale engineering and thus to unlocking the future of the graphene electronics.